As many know, aviation is a major part of modern-day transportation. With this being said, many people have little understanding of how an aircraft operates. The basics of a few aircraft operation systems will be covered, along with a couple new potential technologies. Information will include topics surrounding an aircraft's operation and communication systems. Without further ado, let's get into it. As some might know, communication is a major factor in aviation. One major factor of this being air traffic control, otherwise known as ATC. Clearly, thousands of airplanes fly every day and communicate with ATC. This is a good system until too many aircraft get on the same frequencies. This overloads the frequencies, so to counter this, many other frequencies have been added to areas with high air traffic. This is a simple solution. Well, maybe not. You see, when there are so many different frequencies, aircraft have a number of frequencies to communicate on. This creates potential for aircraft to not be on correct frequency when entering different airspaces. To solve this issue, there are a couple categories of radio communications. These are called area frequencies, CTAF, known as Common Traffic Advisory Frequency, or MBZ, which is a mandatory broadcast zone. Now, focusing more on an aircraft itself. I think it's safe to say that aircraft obviously have computers in them with many functions. One specific function to be mentioned that is very widely used would be autopilot. Autopilot is a system within the aircraft that can keep the airplane in stable flight without direct input from a pilot. This is done in a series of events. First, the aircraft will read the movement and position of the aircraft compared to where it needs to be. The computer will then read these signals and compute what corrections are needed near instantly. The system will then send signals back up to the controlling surfaces or thrust of the airplane to physically make the needed changes. Now that a basic understanding of how an airplane can give and receive inputs is understood, let's talk a little bit about the actual communication process between components of the aircraft. Two main systems are used in today's aircraft. These include manual input and fly-by-wire. A manual flight system uses a variation of different components to move the flight control surfaces. Commonly seen to control manual flight planes are cables that run from cockpit control to control surfaces or flaps, hydraulics, and many different rods to push and pull a variety of components. This provides a reliable control system for an aircraft. On the other hand, there is fly-by-wire systems. Wire meaning electrical wire. In this system, the control inputs made by the pilots are sent to the controlling surfaces in the form of electrical signals. This means that the aircraft's computers can send inputs to the flight control surfaces very easily. Fly-by-wire systems are also reliable but have the potential risk of electrical failure, resulting in an uncontrollable aircraft. If an electrical system goes down, the pilot would have no way to override the system to control the aircraft manually. But don't worry, this is a very unlikely situation and still an excellent flight system that has majorly impacted the modernization of aviation. These two systems work great in aviation, but there is one other system that has had some growing interest within designers, and that is a wireless system. A wireless system would mean that the control surfaces of the airplane would be controlled through radio communication from the cockpit. This would help with weight reduction of aircraft and simplicity in designing, but it's not as easy as it sounds. There is one major drawback to this system, which would be electromagnetic interference within the plane's signals. The inside of an airplane is very reflective for signals, which results in an electromagnetic wave trap. A laboratory in the Electromagnetic and Sensors branch of NASA have done tests that include electromagnetic reverberation chambers, which simulate the reflective environment similar to the ones found in aircraft. This allows models of the EM waves to be created and show how they are created and their effect on degrading signals within the aircraft. Unfortunately, that's all the time we have for this video. Hopefully now you have a basic understanding of how aircraft verbally communicate and the systems that allow them to mechanically and electrically function. Thank you for watching.